Welcome to the law of cosines. First thing I'm going to say is, again, this is useful for all triangles. They don't have to be right triangles, and that's what makes this a very powerful law. We've seen the law of sines, which is very helpful, but it doesn't always do the job. There are situations where the law of sines just doesn't work, and that's when we can use the law of cosines. So let me just run through how the law of cosines looks. You pick whichever angle it is you're focused on, okay? So let's say I'm focused on angle A. All right. I use kind of the analogy that there's three things that go together here, and it's kind of like if you had, say, one hand here and one hand here, and you're kind of clapping your hands together, or it's like maybe you could almost think of it as the top of an alligator and the bottom of the alligator's mouth and the angle in between. These ingredients kind of go together in the law of cosines. They kind of go on one side of the equation, which I'll show you in a moment. Okay, so where do we start? Well, here's the angle, and so the C, just circle it, goes together with angle A and angle B. These three things go together on one side of the equals. Okay? On the other side of the equals, to kind of start it off, is the side across from the angle. So you have to identify, it's this side that starts it off. Okay? That's how we start. So we go A squared, so that side length squared equals. Now, we won't use this A again. We're only going to use, on the other side, the right side of the equals, these three things. So here's what you get. You get B squared plus C squared. It actually looks like Pythagoras' theorem. Then it goes minus 2 times B times C, and then times the cosine of angle A. So that is the law of cosines. That's how it actually looks. Why don't we see it in action? So I'm going to clear this away, or yeah, I better give myself enough room. So I'm going to clear this away, and we're going to draw a little triangle here and see if we can use the law of cosines to find the missing sides. So, okay, so this triangle here, we're told that that's 51 degrees. We're told this side is 14, we're told this side is 16, and we're trying to figure out that side there. Now, how would you know to use the law of cosines? Well, suppose I jumped in with the law of sines. Okay, let me just show you why it doesn't work. Okay, we'll just take a moment here. If I went sine of 51 degrees over x, and then I went sine of, I don't know any other angles, I got too many unknowns here. I can't cross multiply and divide because I don't know this and I don't know this. So it's doomed. It just isn't going to work. So let's not use that method. So we're now going to go and use the law of cosines. So I've identified these three things that kind of go together on the one side of the equals. So on the equal side, on the right side, I'm going to have 14 squared plus 16 squared minus 2 times 14 times 16 times the cosine of 51 degrees. And on the left side here, it's the side across, but remember it is squared. As I say, it's actually the complete Pythagorean theorem. Now all I got to do is crunch the numbers. So let's carefully crunch these numbers. 14 squared and 16 squared. Now here I'm going to go 2 times 14 times 16, which is 448. And I'm going to times that by cosine of 51 degrees. Now, next step, let's just go ahead and put this through on the calculator. We would go 196 plus 256 and minus, make sure you multiply these two things together before you subtract. Think of bed math. The multiplication has to be done before we combine with these numbers here. So we get 170 0.06. Don't forget to square root both sides, and that's going to give us our correct answer. So to however many decimal places you want to go, usually 2, there is the side across from the 51 degrees. And that's the law of cosines in action. Okay, I got one more example to show you. And in this next example, it's another one where I could not have used the law of sines. And you'll see why in just a moment. Okay, so let's say this was my triangle. And let's say somebody comes along and says this side is 27, this side is 20, and this side is 17. I really want to figure out that angle. Well, let's call it angle A. You can see why the law of sines is not going to work, because the law of sines, I don't even know one angle, let alone 2. I mean, it's kind of dead in the water. So I'm going to go to the law of cosines. Now here's the angle. So the 3 things that go together are the 27 and the 20 and the angle. So those are the things you want to put on the right side. Okay, so 27 squared plus 20 squared minus 2 times 27 times 20 times the cosine of angle A, which is what I don't know. And on the left side, to start it off, across from the angle is 17. So we would have 17 squared. Now a little bit of algebra to do here. Let's work out these numbers. 17 squared is 289. And 27 squared is 729 plus 400 minus, then I went 2 times 27 times 20, and I got 1080 times cosine of A. Now I'm going to go ahead and add these 2 numbers together. So I got 289 equals 1129 minus 1080 times cosine of angle A. Now here's the important thing. Don't try to combine these 2. It's not time yet. What you got to do instead is subtract the 1129. Okay, get rid of it. That leaves you with negative 1080 times cosine of A. And on this side, we're going to get negative 840. Now you can get rid of this number by dividing it. So on this side, I'm going to have negative 840 divided by negative 1080. But that equals cosine of angle A. So finally, I got one last thing to do. And by the way, this number here turns out to be 0.7778. And I'm going to cos inverse that. So to get angle A, all I have to do is go cos inverse of 0.7778. And that turns out to be 39 degrees. So there you have it. That is working the law of cosines. And that's all for now.